Okay, so here we will see what is BCD adder. Before starting this BCD adder, first we have to know that what is the mean of BCD number. BCD stands for BCD stands for binary coded decimal. BCD stands for binary coded decimal. So any adder that is used to add binary coded decimal number is known as BCD adder. Okay, so now what is BCD number? Suppose I am writing three numbers here. First I have write 2, then 5, then 8. So what is the binary form of 2? 2 can be written as 10 in binary. 5 can be written as 101 in binary. Okay, and 8 can be written as 1000 in binary. Okay, now the BCD representation. Now the BCD representation. BCD representation of this 2 is 000 It means that if any number is written by using 4 binary number, so it is known as its BCD equivalent. Okay, the BCD form of 5 is 0101. These both are same. Instead of number of bits, here 3 bits are here I have taken 3 bits for binary representation, but in BCD representation any number can be written by using the combination of 4 bits. Here the BCD representation of 8 is 1000. Here the binary and BCD are same. Is it clear to all of you? Here the binary and BCD representations are same. Clear? Okay. Okay. Now by using this binary adder, by using this BCD adder, we can add two BCD numbers. We can add two BCD numbers. Okay. Suppose if I want to write the BCD equivalent of 10. So binary equivalent of 10 is 1010. This one is the binary representation of 10. But when I want to write BCD equivalent, so in the to write the BC equivalent, we first write the BCD equivalent of 1, then we will write the BCD equivalent of 0. So BCD equivalent of 1 is 0001 and 0 is 0000. Okay, so this one is the BCD representation of 10. So I think you can easily understand what is the difference between binary and BCD. This one is the binary representation of 10. This one is the BCD representation of 10. Okay. Now, how can we add two BCD numbers? How can we add two BCD numbers? Suppose there is one number A, such as one BCD number A is 0101. And second BCD number is 6, that is 0110. There are two BCD numbers. This one is the representation of 5, this one is the representation of 6. When I want to add these numbers, so what we will get in the answer? 1 plus 0 equals to 1, 0 plus 1 equals to 1, 1 plus 1 equals to 0, carry 1. So this one is the BCD equivalent. This one is the sum of these two numbers. This one is the sum of these two numbers. Okay, this one is the BCD number. BCD of this one is the BCD of 5. This one is the BCD of 10. BCD of 6. But when we add two BCD numbers, at that time we have to understand two basic conditions. according to first condition, if after addition of two BCD numbers, if our answer is greater than 9, here this 1010 is a representation of 11. 1010 is a representation of binary 11. Okay, so according to the first condition of BCD addition, if after the addition of two BCD number, if the answer is greater than 9, so at that time we will add plus 6, we will add plus 6 with the answer, we will add plus 6 with the answer for getting the BCD. Okay, so here we seen when we add 5 plus 6, at that time we will get the binary equivalent 11, that is greater than 9, that is greater than 9. So what we will do in this time, we will add 6, that is 0 1 1 0. At that time we will add 6, so what we will get, we will get 1 plus 1 equals to 0, carry 1 plus 1 equals to 0, carry 1 plus 1 equals to 0, carry 1. Okay, so at that time, and when we add 3 0 here, so at that time we will add 6 here. So when we will add 6 here, so what we will get, 0 0 0 1, 0 0 0 1 is the equivalent of 1, and 0 0 0 1 is the equivalent of 1. Then we will get the BCD representation of 11. I think it is clear to all of you. Okay, this one is our first condition. Now in the second condition of BCD adder says that after the addition of two BCD number, if we get a carry, how can we get a carry? Suppose I am taking two numbers, suppose I am taking two BCD numbers as suppose I am taking two BCD number as first number is 1001 and second number is 1001. This one is the representation of 8, and below one is the representation of 9. Okay, here I am taking two BCD numbers. This one is 8, this one is 9. So when I add these two BCD numbers, so what we will get, 1 0 0, and this one will be 0, and here I am getting 1. Okay, so here one carry is generated. Okay, here one carry is generated. So these are the two conditions, when carry is generated, and when the sum is greater than 9. At both these time we will add 6 with the data. Got it? We will add 6 with the data. So here we will add 6 in the data, in the answer. So when we will add 6 in the answer, so what we will get, we will get 1 and 7, that is 17. Okay, so when we add 8 plus 9, so we will get 17. So this one is the BCD representation. Okay, I think you all got this point, two conditions. Okay, now to draw the circuit diagram, for this BCD adder, we make a truth table, of full adder. Suppose I am making a truth table of full adder. This one is the truth table, of full adder. In the truth table of full adder, there are three different inputs, A, B, C and D. Okay, but here after the addition we will get sum, so we have to understand we have to apply these conditions in the sum. That's why instead of writing AB, we will write sum. Okay, sum, that is we will write S3, S2, S1 and S0. This one is the sum, this one is the sum, okay, this one is the sum, this sum. So when we add 6 in the sum, when we are taking, when BCD correction is required, BCD correction is only required when carry is generated, first condition. Second condition is that when our sum is greater than 9. Okay, so on the basis of these two statements, we are making a truth table, here. So in this truth table, it is started from 0 0 0 0, 0 0 0 1, 0 0 1 0, 0 0 1 1, 1 0 1 0 0, 0 1 0 1, 0 1 1 0, 0 1 1 1, 1 0 0 0, 1 0 0 1, 1 0 1 0, 1 0 1 1, 1 1 0 0, 1 1 0 1, 1 1 1 0, and the last one is 1 1 1 1. Okay, now these are the input sum, and accordingly we will find out when correction is required. The correction is required is represented as CR. Okay, so when correction is required in the BCD, when our answer is greater than 9, it means that before before 9 before 9 correction is not required, but after 9 correction is required, okay. So by using this truth table, we can easily we can easily find out we can easily find out its equation. How can we find out its equation? One is getting here, so according to this one, the input is S3, S2 bar, S1 and S0 bar. This one is our first condition, same as S3, S2 bar, S1, S0, same as S3, S2, S1 bar, S0 bar. Okay, same as S3, S2, S1 bar, S0 plus S3, S2, S1, S0 bar plus S3, S2, S1, S0. This one is the equation for the correction, BCD correction requirement. So when we solve this equation by using K-map, so how many cells are required in K-map? We required 16 cell in K-map because here 4 variables. Okay, so here I have made the K-map S3, S2, S1 and S0. 0 0 0 1 1 0 and 1 1, 0 0 0 1 1 0 and 1 1, 1 1 1 1 1 1. So this one is the first combination and this one is our second combination. Is it clear to all of you? Okay, now by using this combination, by using the horizontal grouping, what we will get? We will get our first answer CR as S3, S2, and the second, by this grouping we will get answer as S3, S1. Okay, so by using this equation we will draw the diagram for BCD adder. Draw the diagram for BCD adder. This one is the first condition for the correction. Okay, this one is the first condition of correction. What is the second condition of correction? Second condition of correction is when carry is generated. It means that when C out is generated. Okay, so by using our first and second condition, okay, in both these condition, correction is required. S3 S2 plus S3 S1 plus C out, because any one condition is possible. Either this condition will happen, or this condition will happen. Okay, only one condition will be happen at that time. That's why we can add these two conditions. Okay, if any of this condition will fulfill, so at that time the correction is required in BCD addition. Okay, now by using these above equation, we will draw the logic diagram for BCD adder. Now to draw the logic diagram for BCD adder, first we will draw one adder, 4 bit 4 bit adder. We will write 4 bit adder. This 4 bit adder will add this 4 bit adder will add two numbers of 4 bit starting from A0, A1, A2, A3, and B0, B1, B2, and B3. Accordingly, it will provide output. Accordingly, it will provide output as S0, S1, S2, and S3. Okay, so this one is the full adder. That's why we have to represent one initial carry here. So I am representing initial carry C in here, the initial carry C in here, or I represented it as ground. Okay, so this one is the simplest circuit when no correction is required. When we add two numbers, one is A of 4 bit, second is B of 4 bit, so accordingly we will get the sum S0, S1, S2, S3. This one is also BCD number. But when our answer is greater than 9, at that time we need to follow this condition for correction. That first one is S3 S2 plus S3 S1 plus C0. Okay, so for getting S3 S2, I will draw one AND gate here and connect one input here, S3, connect second input here. Okay, now second gate is this one, S3 S2. This one is S3 and this one is S2. Okay, so here from this two in gate we will find out these two mean terms. Now it will add with the C out. From where we will get C out? From this end we will get C out. From this end we will get C out. This one is C out. We will add these three numbers. We will add these three numbers with OR gate. We will add these three numbers with OR gate. Okay, so when we add these three numbers, so it is the equation of correction required. So any of this condition will when any of this condition will fulfill, so correction required output will be 1. So when correction required output will be 1, so at that time the answer will add with the sum is add with the 6. So how can we get 6? To get 6, we will add this path. We will add this path to here. Wait, we will I will draw one line here. Okay. 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 So okay. So when correction required output will be 1. So at that time, okay, so when correction required output is 1, so at that time we will get 1 here and 1 here. Now you can see this one is the combination of 6, this one is the combination of 6. So when correction required output is 1, so we will get 6 here. We will get 6 here. What is this block? This one is the second 4-bit adder. This one is the second 4-bit adder. 4-bit adder. Okay, in which one input is already provided, that is sum, and the second input will be 6. So when we get the correction required output as 1, so at that time the answer is added with the 6, the answer was added with the 6 and provide the final answer and provide the final f0 and provide the final f0, f1, f2 and f3. Okay, so this one is the diagram, this one is the overall diagram of BCD adder. I hope you understand this topic, BCD Adder. Thank you so much.